Okay, so we've talked a lot about inheritance and public inheritance and how public inheritance gives us polymorphism. Public inheritance is by far like the really cool kind of inheritance. Okay, but there are other forms of inheritance. There's protected inheritance and there's public inheritance and private inheritance. And in this video, we're going to switch gears and we're going to talk about private inheritance. So the different kinds of inheritance imply different kinds of relationships. So public inheritance implies the is-a relationship, and that supports polymorphism. Private inheritance implies the has-a relationship, and it does not support polymorphism. So private inheritance is a far more limited kind of inheritance. In private inheritance, the public and protected members in the base class become private members in the derived class. The derived class cannot be used by other objects as if it was the base class. Because it's private inheritance, no one else can see what the object inherits from. And because no other code can see what the object inherits from, you can't pretend like it's that base class. That's kind of an interesting subtlety. You don't know where this object came from. It just looks like a normal object outside beyond its declaration. Okay, and private inheritance means the derived class is implemented in terms of the base class, it doesn't have the is-a relationship with the base class. It's just implemented in terms of the base class. So an example of how we could use private inheritance would be the queue and stack. Now, before I showed you the queue as using public inheritance, just to show you inheritance, but it actually doesn't make a lot of sense to use public inheritance for the queue because we don't really want the public member functions of list to remain accessible within the queue object, which they would with public inheritance. Private inheritance actually makes more sense because everything that's public in list becomes private inside the queue. And so we can control how the queue gets used. Likewise with stack. If we privately inherit from list inside the stack, then we kind of block off all the other list member functions from being used publicly. They become private, and we get to carefully control what gets exposed through the queues and stacks interface. And so we can use private inheritance from list to make a queue or a stack. And then the key thing to remember is that we'll be able to access all the members within the list, all the public members within the queue and stack, but we can't, but from outside the queue or stack, the public members of the list won't be visible. So here's what maybe the stack would look like. So I would say I have a stack and it privately inherits from list. So I'd have a private keyword here instead of public, and then class name list. And then I would have my standard stack interface, right? I'd have push, pop, peek, and empty. And then to push onto a stack, I'm going to push, actually I have a little syntax error. There should be an item here. I want to insert after at the null iterator. So I'm going to insert after at the head. And then pop would remove after at the head. And then peek would just get the item at the head of the list. And kind of just to recall, right, if I get the beginning iterator and ask for the item, then this is equivalent to asking for the item at the head of the list. And then empty, I would again call the empty function that I inherit from list. Now, if I didn't include list : then this would be a recursive call. And empty would just keep calling itself. I have to say, oh, get the empty function out of the list base class in order for this to work as we want. Okay, so you know, all these member functions from list are a part of the stack object. That's why I don't need to prepend the list on any of these other things. I have them available. Empty overrides empty from the base class, and that's why I have to be explicit about calling it here. And by just calling these member functions, we get the functionality from list to add to the front and pop from the front of the list. Okay, so queue would end up looking really different. This just kind of reiterates the point about the empty function. Both stack and list have an empty function. And so we have to clarify which one we mean by explicitly stating the list class using the scope operator. right? So within empty, if I just said return empty, it'd be a recursive call because the empty in stack overrides the empty in list. But by specifying that I want the one in list, this will work properly. Note, this works inside the stack class, but I can't do this from outside the stack class. There's no way for me to say with a stack object, oh, call the object inside list, because that's a private function. And that wouldn't work with private inheritance. Okay, since this is a little bit ugly, we can still take advantage of the using keyword, and we can actually ask that the function empty from list be made available from the stack object. This says to make list empty a member of class stack, this using directive. And so now my code might look like this instead. All this stuff is the same, but here at the bottom I say using list empty. And now whenever I call empty on stack, I'm actually calling empty on list, which works great. And I don't need to re-implement that function. So the private inheritance, as I said at the beginning, it implies the has-a relationship. Because you can't see what you inherit from, you know, no one else knows that that object, that derived object is, you know, no one knows that stack is a list. But there's a list inside of stack. And so we say that a different way. We say, you know, it's not that stack is a list, it's that stack has a list. Inside of stack, there is a list. And so you can use private inheritance whenever that has a concept makes sense to you. So for example, a stack has a list, so private inheritance works. Just making up an example, a computer has a processor. So if I were designing a class to represent a computer and a class to represent a processor, then I might derive computer privately from a processor object. So for example, let's say I had a class processor that I used to model how a processor worked. Then it might have a bunch of stages like fetch, decode, execute, write back, commit. And then when I declare a class to model a whole computer, then it might privately inherit from processor because a computer has a processor. And it would inherit all these things as private members, but then I could use them within this computer class if I'm running a program. Okay, but this doesn't always work. What if you want more than one processor in your computer? Well, then private inheritance doesn't work. Private inheritance says you have one. You has one, right? If you need multiple processors in your computer, then you can't use private inheritance. And then your really only option is to use what you call composition. So within my class computer, I could instantiate, or I could have multiple members that represent multiple processors. So I could have core 1 and core 2 and so on to say that my computer really has lots of processors, not just one processor. So here private inheritance doesn't make sense. When to use private inheritance? Well, use private inheritance when you don't need the is-a relationship, but that you can, when you don't need the is-a relationship, use private inheritance if the new class is implemented in terms of X or has a X. And composition, but composition is necessary when instead of private inheritance, if you need more than one of X. So private just works when has-a makes sense, when you just need one of something and you want to include that one thing within your object. Okay. And you can get away without the is-a relationship. You know, in my experience, private inheritance shows up a lot less frequently than public inheritance. And so probably a lot of the time, you're not going to find, a lot of the time you're going to decide private inheritance isn't right. But every now and then it makes a lot of sense, like with the queue privately inheriting from the list, or the stack privately inheriting from the list. Okay, so in summary, private inheritance gives us the is implemented as and the has-a relationships. But composition is necessary when you need more than one of something.